So greetings of the day, students. So today my main topic that I am going to cover under theory of computation is regular sets and grammars. Okay, so sets are something that you have already studied. If I just remind you of Python, in Python also we have done sets as a type of structure where we were saving our data. In mathematics also at your school level or maybe at your bachelor's level, you have done the sets. So what is a set actually? A set is actually a combination of numbers or maybe characters. Okay, so why we are studying this sets with respect to theory of computation? So as you know that while I was explaining you the transition diagram, if you remember the transition diagram that I was helping you with, every transition diagram has an input of the type A, B, AAB, or of the type 00111, like that. It means the input alphabets to that transition diagram could be either of the type A, B, or of the type 01. If that transition diagram accepts it, you consider that it is accepting it. It means if you, with the help of that string, are able to reach to the final state, so we say that yes, this transition diagram is accepting it. Otherwise, we say it is rejecting it. So by accepting it, I mean that that particular input string, for example, A, B, B, A, if it is accepted by a transition diagram, so I will consider that that input string is actually a part of the language that machine understands. Okay, let me give you another example here. Okay, so if I have a transition diagram of the type, see that I have a transition diagram, right, which has 3 states. The name of the state is Q0, which is my first state. The name of the second state is Q1. The name of the third state is Q2, for example. And here this Q2 is suppose my final state. Okay. And then you always represent it with some inputs. Okay. So like this, so suppose on Q0, if you pass 0, so maybe it goes to Q1. Okay. And to Q0, if you pass 1, so maybe it comes back to Q0 only. It's just a random example I am giving. So I am done with Q0. Now for Q1, if I pass it 0, so it will reach to Q2, right? And if I pass it to 1, so suppose it goes back to itself. Similarly, for Q3, if I pass it 1, it goes here. And if I pass it 0, maybe it goes back to here. This is just a random example. Okay. And then what we do, we always, now this is a machine. When I am representing it, so this is my finite, you can say deterministic finite machine. You always say it like this, DFM, deterministic, right? Finite machine. So this is how you write it. Okay. Sometimes I call it that it is students deterministic finite automata. Sometimes I call this as your transition diagram, right? So all these are the names of the same. Okay. So whenever you operate on a machine, you know that machine understands some commands. Every machine understands some commands. For example, your computer is a machine. If you press enter, what happens? The control automatically goes to the next line. Your mobile phone is also a machine, right? So what input you give to it, if you just click on the Instagram icon, so it will take you to the Instagram. Okay, it means the input that you giving it, the command that you are giving it, or you can say the language with which you are talking to it, it should understand that language. Only then it will be able to work on it. For example, if I give you your example, suppose that there is a student in your class who understands Punjabi. Okay. So how I can communicate, how I can give commands to that student, how I can give input to that student. So that student doesn't understand any other language, only understands Punjabi. So my commands, my input to that student should always be, my language should always be Punjabi, because that language is understandable. Similarly, whenever I give it an input, if it understands that input, so it actually helps you to reach here, right? Similarly, here, if I'm explaining you that we are dealing with regular sets and regular grammars, this is our topic for today. So grammar here means that language that your machine understands. Which machine? Finite automata machine. All the types of grammars, right? If I give you another example that a student is understanding only English, suppose. Let me just erase it and start it fresh. That there is a student who only understands English. So consider that this student is actually a student, or you can consider that if I am talking about finite automata, so it's a machine. Now it understands only English. It means my commands to this student should be only of the type English. Okay. So if I just create a set for English language, what type of string I can give to that student? So it will be a set of this. You agree with this? A, comma, B, comma, C, comma, D, comma, E, comma, F. So the language will be a set of all these strings only, because English is made up of only these strings. You can write them in lowercase also, and you can write them in uppercase also. So this is your set of that language that the student understands. So this is set. Okay, so I am doing the same for machine also. On the other side, if I talk about, this is set, other one is grammar. Okay, or language. So if I write I am a student, so don't you think that it is a grammar now, understandable by the student? It is a language. On the other side, if I randomly like something like this, X, Y, Z of is A, ABC. So this is actually a language, but it is grammatically not correct. So this student will not be able to understand it. Although it is made up of the set of English language, but it is a language which is grammatically incorrect. So this student will not understand. Okay, so now in place of this student, I will explain these two concepts, set and grammar, for finite automata. Okay, so let's start. So what is grammar actually? If you talk about this term, grammar, right? So in the literary sense of the term, so grammars, they actually denote any rule, right, for conversion in natural languages. There are so many grammars, right, for the natural languages like English, Sanskrit, any Mandarin, Punjabi, Hindi, etc. So for every language that you work on, that language is created only because of certain grammar rules that it follows. Okay, so for example, if I'm talking about a sentence, I am a student, so this is a language, but this language that I have written, it follows grammatical rules. So what kind of grammatical rules it follows? It follows that with I, you always have to write am, and if it is I am, you always have to write a after that. You can't write it like this, I are a student, because I is always a singular thing, and with singular things, grammar says that you always write am and not are. You write are only with the plural things. Okay, so this grammatical rules, these syntactical rules that work on the, why the term syntactical rules are written here, because it works on the syntax. In case of Python, if you remember that the syntax for print is print like this, right? In double quotes or single quotes. If you violate this syntax, you write it incorrectly. You write instead of print in double quotes, you write it like this, and then you forget to close the bracket. It means you have violated the syntax. You have violated the syntactical rules, or you can say you have violated the grammatical rules. Okay, so grammar rules, syntactical rules, or syntax, these all are kind of same things. Okay, and any language follows the syntactical rules. If you don't follow the syntactical rules, the language will get incorrect for you. Like here is an example: I are a student. It's a wrong use of grammar. It's not a language anymore. Okay, so the theory of, now we are working on finite automata, and we have formal languages. And even in the field of computer science, you are using so many languages. So if I talk about programming languages, that is one example, right? Now we are working on regular grammars and languages, right? This topic is all about regular grammar and languages. Okay, so Noam Chomsky gave a mathematical model of grammar in 1956. So this grammar model was actually created in 1956, not for English. You know, English is really, really old. This 1956 model created by Noam Chomsky were for those languages which are being written for the computer. It means those languages which your computer can understand. The grammar for English, the grammar for Hindi, the grammar for Punjabi or any other languages, they are really, really old. Maybe before Christ. You can't even judge how old they were, right? But for particularly the computer languages, the grammar model was developed by Noam Chomsky. You know, computer, your machines are also kind of computing language, computing things. Okay, so that was created in 1956. So if generally I talk about that grammar, the grammar that your computer understands, so we how define it? We can say that it can be formally written as a 4 tuple. In case of TOC, everything is represented in the form of some tuples. Okay, so grammar is made up of 4 tuples. What are the symbols in those 4 tuples? N, T, S, P. Okay, so now let's see what this NTSP actually is. So N means, it is a, you call it N or you call it VN. Okay, so it is a set of non-terminal symbols. Now we will discuss non-terminal symbols in the further slides. So N stands for non-terminal. Okay, after that you have T. You represent it with the T or you represent it with this summation sign. Okay, and it is a set of terminal symbols. We will discuss what is the difference between non-terminal and terminal symbols. But till now, you have to just focus that your grammar is made up of 4 tuples N, T, S, P, where N are the non-terminal symbols, T are the terminal symbols. Okay, now what is this S? Now S is a special variable and it is called as the start symbol. Okay, it is a starting symbol, and can you see here this expression says what? It says that your S is actually, it actually belongs to non-terminals. So if you have some non-terminals, like this is a non-terminal set, A, comma, B, comma, C, these are non-terminals. So S is actually one out of it. So S is actually a subset of it. So maybe your S can be A or your S can be B. So your S you create from the non-terminals. Okay, so this S belongs to non-terminal means S you have to create a start symbol. From where to start? Whenever you start your sentence, there is one starting word. Okay, so S actually belongs to any 3 of these, A, B, or C. Now P is the production rule. What your P is? P stands for production rules for both your terminals and non-terminals. Okay, and what is the form of your production rules? It is of the form alpha goes to beta. So P, how you represent P? You write P like this. It goes from alpha to beta. What are alpha and beta? Alpha and beta are strings. Okay, and these strings are made up of VN, that is your non-terminals, union terminals. What does it mean? That your strings are only created by using non-terminals, union terminals. It means the string has letters from non-terminals and terminals with the union in it. Union means you don't prefer the repetition. Okay, and at least one symbol of alpha. You know, on the left side we have alpha. From the left side, at least one symbol of alpha, it should be from non-terminals. It means the starting alpha should have at least one symbol from non-terminal. So suppose this is non-terminal, so at least one symbol should be from non-terminals. It can have more than one symbols also. Okay, so I don't know if this is clear with you, but if I do an example with you here. So this is a set. I told you that your set is made up of N, T, S, and P. Okay, so here if I represent, this is N, non-terminals, these are the terminals, this is the starting symbol, and this is a production. So this is a grammar. Suppose the name of the grammar given is G1. This is a random name. Okay, and it is a made up of non-terminals. So non-terminals are always in capital letters. You always write them in capital letters. So N set is actually S, comma A, comma B. This is the set of non-terminals. Then terminals, they are always in lowercase. So suppose I have two terminals, A, comma B. So if you remember, this A and B are actually those which you provide to your machine as a strings. You remember a string, we have given it to A, B, A. Okay, and this S here, it says that this is a starting symbol. So S is from your N, where I write S belongs to N. So it is a part of your N. And now there is a production. So these are the production rules. Can you see the production rules are of the form alpha to beta? So this part, the left part is represented as alpha, the right part is represented as beta. Again, this left part is represented as alpha, right part is represented as beta, and so on. So production rules are always of the form alpha and beta. And what was mentioned, that in alpha, at least one symbol should be from non-terminal. Can you see? Here S is a non-terminal, here A is a non-terminal, here B is a non-terminal. Okay, so this grammar satisfies all the rules of the grammars. So here it is written again, whatever I have mentioned, S, A, and B are the non-terminal symbols. A and B are the terminal symbols. So non-terminal symbols and terminal symbols, what is the difference? Non-terminal means that are not ending. Actually, they are starting something. Can you see from here? Something is starting. If I write it like this, let me write this grammar for you. S, A, B. Then A, B, and B. So out of this is non-terminal, this is non-terminal, this is non-terminal. Why I am saying it is non-terminal? Because it is not terminating something, it is not ending something, it is actually starting something. It is starting a production. On the other side, if I talk about these two productions, this is a terminal symbol. Here the production is ending. Here the production is ending. After that, there is nothing. Okay, this is an exception. Here you will ask me question, okay ma'am, here non-terminal is starting and it is also ending by non-terminal. This seems to this like you, okay, for you. But if you write it like this, A and B, and you replace, how you replace your A? You can replace your A with this small a. Can I write it like this? Your A, can you see A reaches to A, so I can replace my A with A. B reaches to B, so I can replace my B with B. Can you see this production has now turned into terminal and non-terminal with the help of these two productions? I told you that your grammar, right? Grammar, right? It is made up of how many tuples? Total 4, right? Non-terminals, terminals, starting symbol, and last one is the productions. Production means when you are actually generating a language. Okay, so as you know that this is not an English language, so the productions you will not be able to understand what is the meaning. Okay, but I will try maximum to explain you here. Okay, so first of all, what is this N? N are the non-terminals. So if I tell you what are terminals, so terminal in general, it is mean terminating. Terminating means ending something. Okay, so if something is ending, it means it is terminating, terminal. But if something is not ending, instead it is starting, that is known as non-terminal. It is not terminating, it is starting something. Okay, and I tell you that your N is made up of only the capital letters. So for the current language, it says that your N is made up of S, A, and B. Okay, now second thing is terminals. Terminals means with which you are terminating something. Okay, so suppose if I give you an example that in English you terminate everything with a dot, like a full stop, or with a question mark or something like that. Okay, but here your terminals are always in small letters. Okay, so suppose the terminals are of the type A, comma B. So from here it will start, like suppose this S is the. Most of the lines in English, they start from the or I. So this is an example that from where your sentence is starting and where it is ending. So non-terminal say it is starting from only the capital letters, and terminals in finite automata is represented by the small letters. Okay, then there is a starting symbol. Starting symbol doesn't mean that your language always starts from that. Okay, but you all in a production, you always start a production with a starting symbol. If I'm writing a production, so the very first thing is always starting from a starting symbol. Okay, and I told you that your S is actually a subset of N. It means your starting symbol will be one out of these. It can be A, it can be B, or it can be S. So here your starting symbol is S, this one. Next, the productions. So productions are always of the form alpha to beta. So for the current grammar, your production is of the form, it is of the form S goes to AB, comma, A goes to A, B goes to B, like this. So if I explain you these two productions, can you see that it proves the concept that it starts from the non-terminal and it ends with the terminal. You know, A is a non-terminal and capital A is non-terminal and small a is terminal. So from here it is starting and here it is terminating. Similarly, this B is a non-terminal because it is starting the production, and the small b is the terminal because it is ending the production. So you will be satisfied with my explanation for these two productions. Okay, but if we talk about this production, the very first production, so you will be saying, ma'am, okay, you are saying that it always starts with the capital letter and ends with the small letter. It always starts with the capital letter and ends with the small letter. So, but this is not the case with it. It starts with the capital letter and it ends also with the capital letter. So I will say that at any time you can reduce this production. So how I am going to reduce this production? So I will write SAB, which is my production, which I found that it is not right. Can I replace this A, the very first A, with small a? Why I am replacing it? Because capital A is represented, it is reaching to small a. By using this production, I can replace this capital A in the first production with the small a. Similarly, by using this production, which says that your capital B should be replaced by small b, I can replace this B with a small b. So now can you see that this S reaches to A and B, and this is a non-terminal symbol. It means these are capital letters and these are terminal symbols. So I have converted, I have reduced this to the form of a grammar. So this is grammar G2. Okay. And what are the non-terminals? Non-terminals are S and A. It is made up of only two non-terminals, S and A. In the previous example, that was made up of three non-terminals. Okay. it is made up of two non-terminals. So this is a grammar created by ourselves for your help. You can create a grammar of any type, or maybe in an exam I will give you a string like this, and I will ask you to just tell me which is non-terminal, which is terminal, which is starting symbol. So it is very clear from it that these are the non-terminals, these are the terminals. So your terminals are made up of only A and B. So S is again your starting symbol because it is from your non-terminal. Then the production has how many rules? So always you say that these are the production rules. Whenever you produce a language using the grammar, you have to follow the rules. So these productions are actually the grammatical rule, or you can say them production rules, or simply rules, that from this will be produced, from this will be produced, from this will be produced. Okay, so there are how many productions? There are 3 productions. S goes to A, capital A, B. Okay, this is the first production. It has at least one non-terminal symbol. Next is A, and it is made up of A, and B. Okay, now the left hand side has at least one non-terminal. This is the requirement. It can have terminals also, but at least one non-terminal should be there. On the right hand side, you can have anything. You can have terminals or non-terminals. Okay, and the non-terminals, they can be replaced. How they can be replaced? Can you see the third production says that every A can be represented with the null. This is a null character, nothing character. So wherever there is a, can you see I can convert it into that SAAB. So if I just replace this A with the null, what will happen? It will become AB only. This will be removed. Okay. In the second one, AAAB. So if I just replace this A with the null, so I am left with only AAB. Okay. So this is how I can reduce my grammar. So S and A are the non-terminals, AB are the terminals. This is an empty string. S is the start symbol because it belongs to the non-terminals, and productions are, these are the productions.